Hi, my name is Aditya, and this is a small presentation on a project that I did, small project that I did as part of Task-1 of Orinson Technologies internship, and is to develop a function in images with the focus on accurately detecting and classifying objects and ensure forms. The model performs well across different scenarios. Used is Google Colab, Detector module, Matplotlib, and Torch Vision. So these are the steps involved in building custom object detection model. First, we must import data. We must pre-process the data. Then we train the model, and we do the predicting of object labels. So what is Detector? So Detector is an open source library for computer vision programming that helps us in fitting state-of-the-art computer vision and object detection models into our image data. So one of the great things about this package is that we can fit these models using very few lines of code. So we can install Detector using the below line of code, pip install Detector. So here in Google Colab, I have installed Detector package, and as you can see here, I have also the Detector as part of the installation. Matplotlib, OpenCV, Python, Pandas, Torch, and Torch Vision, and also NVIDIA CUDA packages have all been installed, which are essential for performing object detection and computer vision. So for this, we'll use the GPU to train the module so that the process can get over faster, and also because of the size of the model is higher. So for using the Detector library to build and train a model on the custom dataset, we use 5 lines of code. So these are the 5 lines of code, wherein the first line we are importing the model and the dataset model. The second line is for defining the instance of data. Third line is for instantiating the models, and the fourth line is to train or fit the model with the data, and the last line will tell us the prediction of the model. So the data set is actually from here. This is by the official Detector developers, and this zip file actually contains, this is zip file, and this zip file actually contains 300 labeled images of dogs, chihuahuas. So we are going to train a model to detect dogs. So now we can mount the data. We can mount the Google Drive using this line of code, and we can change the working directory to the dataset folder, which is present in Drive, to the current one that we are working using these below lines of code using change directory function. So here in Google Colab, as you can see, I have changed the working directory to the dataset folder in Drive. The dataset is actually present in the Google Drive. So for converting XML files to CSV files, we use these lines of code. So here, as you can see in my Colab file, the Detector package has a module called utils within it. With that we can convert utilities model. With that we can convert the XML files to CSV files. As you can see, the XML files have been converted to CSV files. Now we can visualize an image from the data, a sample image. So we import the Matplotlib packages, and we now plot the image. So this is a sample image here. As you can see, this is a sample dog image. So we now pre-process the data. So to work with this library, we are required to pre-process the data according to the utility of the library in this section. And in this section, we will look at how we can use Detector library. So to perform the processing, we do these steps: transformation of image, combining images and labels, and image labeling. So to pre-process the data, in these lines of code, we can do the transformation. So we are defining a series of transformation to apply to the images present in the dataset. So we are converting the image to PIL image format, and then we are resizing the image to 800 pixels, and then we randomly flip the image horizontally with a probability of 0.5, and then we convert the image to a tensor, and we normalize the image, and also we normalize the image. So yeah, now we can now transform image and combine and label the train images. One second. So we are transforming the images here, and we are visualizing one of the images. After performing all these functions, this is the result we get. This is the transformed image after all the transformations have happened. It's a sample image of the transformed images. So we have performed the transformations required for training the model. So now comes the model training part. So after pre-processing the data, we have our model. We are going to use the RCNN Resonate 50 model. So this will be done in two steps. We will instantiate the data loader, and we will instantiate and fit the model. So instantiating the data loader now. To fit the data into the model, we are required to instantiate an object as a loader that can hold the data. So these lines of code will do it. So we are now instantiating a data loader here. This will fit the data into the model. We are required to instantiate an object, and we will now feed the data loader instance to the image classifier here. Now we are required to make the model know that there are categories. These are the categories that are in the data. We can do this while instantiating the models. So that there are two categories. One is Chihuahua and Golden Retriever. These are the two species of dogs that are present in the data set. So these are the categories. So we are now instantiating the model with the categories. So after that is done, now we are ready to fit this model into our training and validation data. So this will do the train model. This will run for with this line of code, it will run for 20 epochs. Yeah, it will run for 20 epochs, and now after those 20 epochs, we can now see that we can plot the losses from the model, and as you can see, for every epoch the losses have been gradually decreasing. Now after the training is now complete, so we are now displaying some of the images. So with the for loop, we are displaying some of the images, and we are now visualizing in a plot. So these are the trained models, and as you can see, the model is able to identify the dogs with accuracy. So this is my mini project that I have done for Task-1.